Welcome back to the Deep Dive. Today we're doing something a little different, a really focused plunge. We're moving away from the huge trends and looking at one tiny design choice that honestly dictates how clear your code is.
And we're diving into Haskell module imports, specifically using a really popular library for building command line tools, optparse-applicative.
Exactly. And our source material here is this great set of notes from a developer who's, just getting their feet wet in the functional world.
And they spotted something immediately, that how you bring code into your project has these huge, huge consequences, especially when you're just starting out.
It really does. So the mission for you listening to this is to get the trade-offs between 3 different ways to import code. Doesn't matter if you write Haskell or Python or whatever.
It's not about the syntax, really. It's about cognitive load. It's about how much confusing information you're throwing at yourself when you just open a file.
Yeah, and the developer's notes really nail the initial problem, especially in Haskell. They said cryptic symbols and functions seem to just appear out of nowhere.
And that just turns what should be a simple task into a super stressful debugging session.
And the goal here is as simple as it gets. We just want a tiny command line app. Let's call it X2 ebook. All it does is show a help message when you type X2 as help.
Right. The output is just usage, XS2 ebook, available options, help, show this help text. That's it.
A simple goal. But making the code for that simple goal readable? Well, that's where this deep dive really begins.
Okay, so let's start with the first way, which is what a lot of people do first, the black box of global imports.
Right, the minimal code, the kind of thing an AI might spit out because it's the fewest characters. Line 1 is just import options out applicative. That's it, the whole import.
And then the code that runs it all, the main function, is super short, but it's also completely opaque. Line 4 is main XX parser info empty helper need them.
Okay, I have to be honest. If I saw that for the first time, I would just close my laptop. I mean,
Yeah.
it's so concise, it's almost hostile. You said options.applicative is imported globally, but wait a second, isn't that normal? Like in Python, you just say import requests, then request.get. What's so bad about it here?
That's a really good question, and it gets to a key difference between, say, object-oriented and functional styles. In Python, things are usually attached to an object, like that requests prefix. But in Haskell, everything is a function. And a lot of powerful functions have really short, generic names, like ilm in our example.
Ah, okay, I think I see. So if I import 2 different libraries, and they both happen to have a function called, say, run or eval,
You've got a problem.
I have a massive conflict right in my main workspace.
Exactly, a namespace collision just waiting to happen. But for a beginner, the bigger issue is, well, it's cognitive. Because everything's imported globally, I have no idea if XX parser is a standard Haskell thing I should already know.
Or if it's something specific from this one library.
Precisely. The cognitive load isn't about what the function does. It's about figuring out where it even comes from. It's pedigree.
So I'm constantly having to check the docs just to figure out, is this a core part of the language or from this new library I just added? That sounds exhausting.
It is. It forces you to treat that whole line of code as one single indivisible thing, a black box. You know it works, but you don't know how the pieces fit together.
So it's minimal, but it gives you maximum mystery. Not a good trade-off.
It's a habit we try to break early.
Okay, so if that's the worst way, let's swing the pendulum all the way to the other side, towards total clarity. That brings us to the second approach, qualified imports.
Yes. And this method is, it's the gold standard for learning a new library. It solves all those problems we just talked about.
So now the code on line 1 looks very different. It's import qualified options, applicative as opta. We're giving it a nickname.
And that little nickname changes everything. The impact on the actual code is huge. That messy line 4 now explicitly prefixes every single thing that comes from that library. It becomes opta.execparser, opta.info, opta.empty, opta.helper, opta.adm.
Wow. Okay. If the first one was a black box, this is a glass box. It's crystal clear. Every single one of those weird functions, execparser, info, empty, they all have a giant sign on them saying, I belong to Opta.
For a beginner, this is incredible. You get a compiler error on opta.execparser, you know exactly whose documentation to go read. It forces you to see the connection between the function and its source.
And I can see how this would be amazing if you had 2 libraries with conflicting names. You just import one as lib and the other as lib. Problem solved.
It completely eliminates namespace collisions. The code becomes super reliable and traceable.
Let's go. I'm already getting tired just looking at it. It feels so noisy. I mean, if you're only using one library, having to type opta 6 times in one line feels like a lot of clutter. It's visually distracting.
That is the drawback. The source notes call it clear but cluttered, which is perfect. You get 100% clarity on where things come from, but you lose readability because of all the repetition.
So you're trading one problem for another. Is the visual noise worse than the mystery? That's the question.
Right.
Okay, so we have two extremes. The minimal mystery of just dumping everything in and the cluttered clarity of qualifying everything. We need a third way.
A middle path.
Something that gives us clean syntax without making us guess where everything is from.
And that brings us to technique number 3, which is pretty much the professional standard for this kind of thing: explicit imports. The best of both worlds.
This one feels like it forces you to be deliberate. You have to declare your intentions at the very top.
Instead of grabbing everything or renaming everything, you just make a list of the specific tools you need for the job. Take us through that import line.
It's a big change. Line 1 now looks like this. Import options, that applicative, and then in parentheses, a list. Exec parser, info, helper, item, empty.
That one line is a masterpiece of communication. For anyone reading your code, it does 3 things instantly. First, it's documentation. I know right away that those 6 symbols are your external dependencies. Second, it limits the namespace pollution. You're only bringing in 6 things, not hundreds. So the chance of a conflict later on is tiny.
And third, and this is the big one, because we've listed them out, we can now use them without the opta prefix. So the code goes back to looking clean: main, cray, exec parser info, empty helper, idom.
It's perfect. You get the concise, easy-to-read function body, but the mystery is gone. A reviewer can glance at line 1, see the list, and then know that any other function in the file must be a standard built-in part of the language.
I think what's so powerful here for any programmer is that it forces discipline. It's a bit like in Python when you do from library import funcagb.
It is.
You're forced to be intentional about what you're adding to your code. And if you later remove exec parser from your code, the compiler can tell you that you don't need to import it anymore.
It's self-documenting, and it's a compiler-enforced dependency tracker. It's just the ideal balance for real-world code, where you need clarity, but you also need efficiency.
What's really wild is that we've spent this whole deep dive talking about one line of code, line 1,
Yeah.
the import line. And we still haven't really touched the actual magic happening on line 4.
That's because the most important decision for long-term clarity happens right at the start. You can't understand the recipe until you know the ingredients and where they came from.
Okay, so let's recap for everyone listening who might be feeling that information overload when they're learning a new language or a new library. You have a strategic choice. It depends on your goal.
First, you have the global import. It's fast, it's minimal, but it creates a black box. It's the worst choice for learning or for code you plan to maintain.
Second, the qualified import. This is perfect for learning. Crystal clear origins for everything. But you have to live with the visual clutter.
And finally, the explicit import, the professional's choice. You get clean code, but you also get a clear manifest of dependencies right at the top of the file. It's the best balance.
So we fixed the clarity of the imports. We know where all these pieces are from now. But the core puzzle of functional programming is still just staring at us from line 4.
Oh, absolutely. We've only solved half the mystery. We still have this collection of functions: exec parser, info, helper, idiom, empty, that somehow magically assemble a working command line interface.
And the really scary part? The operators. Those strange symbols in Adam Delata that seem to be doing all the real work of gluing everything together. Why do functional languages need all these weird symbols just to connect functions?
And that right there is the essential next step. Understanding of those operators and what functions like empty actually do, that's the bridge to really getting the power of this paradigm. It's a leap from just calling functions to composing them.
Well, that sounds like a perfect challenge for a future deep dive. Thank you for joining us today as we figured out the critical and honestly often overlooked decision of how to import clarity into code. We hope this makes your next encounter with a new library a little less intimidating.
We'll see you next time.